Hi guys, welcome to my channel. I am back with more electrical circuit problem. I will still be solving this is a different problem. It involves and it's a sort of an experiment. So as you can see the question paper on your screen, it says that grade 12 learners are doing an experiment to determine they want to find the EMF of the cell or sort of the battery, and then also to find the resistance of the cell. So those are the two unknowns that variables that learners want to find in the experiment. So I just drawn the graph using the data. You can see is what voltage versus current graph. Current is measured in amperes as we can recall, and then the voltage is measured in volt. And the very first caution in the experiment that learners have to learn, you have to realize that this voltage which has been used to plot the graph. This is the Vload, V external. This is actually the Vload, the voltage going to the external resistance. So you used to overcome the external resistance of the cell. The current is passing through this amperes. So that is the total current passing through that circuit. As you can see, now we have got the very first question. It says that, as you can see, that the graph is a straight line. So the first question is, what factor must be kept constant during the experiment? We must keep the constant the following. If we want that graph to maintain that straight line, we must keep what constant? The temperature of the battery, and also what the temperature of the conductor. So temperature, basically temperature must be kept constant. Temperature must be kept constant. As you know that Ohm's law, from the definition of Ohm's law, if we want current to be directly proportional to the voltage, we have to, or inversely that relationship to be maintained, we have to determine what the external, we have to keep the temperature constant. So we will analyze this graph and determine the factor. This is y-intercept, and then this is x-intercept. So as you can see, so the very second question, we have got the second question from this very first question. Now the second question requires me, as you can see, the graph is a straight line. This is a straight line graph. So if it is a straight line graph, as we can obviously see, this means that it must be maintained, or it must be defined by a straight line. That is correct. So the equation of a straight line standard form is given by y mx plus c. So this is what the input, this is the input. This is the input. As it goes on, this is what? This is the gradient. This is the gradient. This is the gradient. This is the gradient. And then this is what? This is the output. Output, the y-intercept is the output. And then this x is what? Is the input. X is the input. And this is what? Output. This is the output. And then what is this value here from the equation of the straight line? And this is the y-intercept. Y-intercept. Now, what variable do I have? What are the unknown variable that I have? I have the EMF. EMF, as you know, is given, but I also have the internal resistance. I have the current passing through this resistor, and then current is the input. It will have to be the input. So I want to write this equation. Let me complete it. Then it says R plus internal resistance. So I'm going to say I is equal to this is variable resistor. This one. It says IR plus IR. Then I have the internal resistance. I want to determine it. So it must be there as part of the equation, as part of the unknowns. I want to write this equation so that it corresponds, or it turns out to be in the form of a straight line equation. So such that I will know what variable corresponds to the output, what variable corresponds to the gradient, what variable corresponds to the input, and what variable corresponds to the y-intercept. So let me just continue working on with this equation further. So you can see that on the y-axis, I have the voltage. I don't have IR. This voltage is actually measuring the Vload voltage going through, used to overcome the external resistance. It says that E is equal to V load plus IR. I want to make V load something the formula, because this is the V load here, so it must be substitute the formula. I'm going to say from here, I'm just going to continue say Vload is given by minus IR plus E. So let me just start with R. Vload is given by minus R times I plus E. That is what we can see there. So E, this is familiar to the equation of a straight line. Y is the output, y-axis, this is y is equals to m is the gradient, x plus c. So I know what each factor is or what each variable is. So the Vload, the voltage is the output is y as per the standard form of equation of a straight line. Then internal resistance is what? Is the gradient. Internal resistance is the gradient. So whenever I'm required to calculate the internal resistance, I have to count internal resistance. I have to know that I have to calculate the gradient of the graph. As it goes on, current is the input, so current is correspond to x. As you can see, there is on the x-axis. So y, the y-intercept is the EMF. Like the first question we are dealing with here. So I have related the variable of my equation with the equation of a straight line. So we can proceed from here. Now I want to determine the EMF of the cell. I want to determine the EMF of the cell. Where is the y-intercept? This is where the y-intercept is. This is where the y-intercept is. So we'll have to excuse my graph because it's not a drawn to scale. The graph is not drawn to scale. This is a freehand drawn graph, but it will allow me to still be able to explain. Then what is the value? I can say EMF is given by EMF, the value here of y can be 7.5 volts. So the EMF of the battery is 7.5 volts according to those estimations. So how do I know what tells me to go to the y-intercept? It's the standard form of the graph. I arrange my graph such that it corresponds to the standard form of a straight line. Vload is the y-intercept, and small letter r, you see, is negative. So the gradient is negative. So minus that, this minus, hence there is this minus, and then the input, and then the y-intercept. Y-intercept is what? Is 7.5. Y-intercept is represent our what? Y-intercept clearly represent our, we've got it represent our what? It represents our EMF. So EMF is 7.5 volts. So those are the units of EMF. So as you can see, the question was worth 2 marks because you have to know where to look from the graph. You are using the graph. Now let us continue with more interesting questions. The equation we have just analyzed, or we just came up with, and then we have just basically arranged, is very, very important because it guides us. Without this equation, we cannot solve this equation. We cannot solve this problem. Then we have got Vload. Vload is given by minus R plus EMF. I have just determined the EMF. Now they want us to find internal resistance. Internal resistance. So I already know that internal resistance, this value, according to the equation of a straight line, as per standard form, I have to find the gradient of this line, the gradient of my graph. The gradient of my graph corresponds what? To the internal resistance, small letter r. Let me just find the gradient of the graph. I want to quickly find the gradient of the graph. I'm going to choose the coordinates. As you can see, the gradient of the graph is given by what? It's given by r over r, which is change in voltage over change in current. Change in current. This equation is the one gradient. R is given by, you can say V2 minus V1, and we say I2 minus V1. I2 minus I1. Now I'm going to find random coordinate from that graph. And let me just find. Let me just choose the random coordinate. I'm choosing the true coordinate here, and this one is this is the current. So current is x. In terms of coordinates, I can just write. Let me just write current in terms of coordinates. I'm just estimating there. It appears to be 1.5 is 0.15, 0.15, and what is the corresponding, and 6. So it is what it is. This is what x y1 and v1, and then I'm looking for y2 and what, and v2. So let me proceed with my my calculation. I'm proceeding with my calculation. Then as I proceed from there, I've got I2, the second current is 0.45, and then I've got and what, and 3. Now let me quickly calculate my gradient. As you have seen, it will be negative gradient. And then from there I have got V2. V2 is 3 minus 6. 3 minus 6. And then I2 is 0.45 minus 0.15. We can see that the internal resistance is minus 10 ohm. And it's a very big value, unusual value for internal resistance, but that is what it is. Our calculations are what are accurate. And then from there, we can just find that the internal resistance is minus 10 ohm. They say we have to only, we are not allowed to use these equations according to the question. So we have to strictly use this the gradient format. So the gradient method. So that is what we have come up with. The internal resistance is 10 ohms. As you know that the field of internal resistance cannot be a negative field. So that is what we have. We will continue solving more problems requiring involving electric circuit with experiment. Thank you.